And hello. Welcome to the ASP.NET Community Stand-Up at a crazy different time. Shuffled things around. I was actually, this morning, I was on a, what was it called? Ask the Experts for ASP.NET Core APIs. And somehow, by some mistake, I was an expert on this panel.
You were there?
I was there.
Strange, John. Yep. I'm kidding. You're an expert.
So
you know stuff.
This is part 4 of the ASP.NET Core Architecture series with Damian and David.
Part 4 of what? Part 4 of
N.
25?
Part 4 of N, of the ongoing drama.
How many slides are in the deck? Can we predict this?
It keeps growing.
Yeah, it does.
Does it?
It's longer and longer.
Oh my gosh. Well, awesome. Okay, I want to jump right into this. I also love community, and it's important to go through the
John loves community
links. So here, let's do it. Okay, as always, I share these out. They go out in the chat. They will go out in the chat. Here we go. Woo. All right, and I just have to call out, we got friends from all over. We got Egypt, we got Korea, we got Argentina, and we got Cincinnati. So all over the place. Oh, Canada up there too. Hello, friends. Okay, let's do it. So first of all, this was an interesting one. Hassan talking about up and running with OData and ASP.NET Core 6. So talking about how to set this up, get this going. And so he walks through the setup, his example using .NET 6 and Visual Studio 2022. So he creates a new application, and then he installs OData. So that's using the NuGet package. So it's just installed as a NuGet package, and then up and running. And then he shows the wire up there. So the configure services and just add a controller and the OData options. So pretty straightforward. Definitely handy. You know, I talk to people that have existing applications. They've built something out with OData, or for whatever reason, OData is a great fit for them. It's cool. OData is available as a NuGet package under .NET Foundation and everything. So that is neat. And then one other thing, he just kind of sneaks in here. So of course he shows off all the filtering and the order buys and all that sort of stuff. He sneaks this interesting thing in here, and I'm going to be paying attention to this, the future of OData. So the OData team and he are looking into this OData version next, and looking at making things more modular, technology agnostic, etc. So he gives a GitHub issue that you can follow along there. So, interesting stuff. This is neat from Niels talking about building a Discord bot. And when he sent me the link, he's also like, hey, David Fowler commented on this, that he liked it when he tweeted about it. So this is pretty neat. This is using the worker template. So he goes through, first of all, through Discord, doing the setup, creating an application, configuring the scopes and all that sort of stuff. Once that's done, so here the scope is associated with bot permission. And then he uses the worker template, and so creates that and goes through, and he's hosting this using Azure Container Instances. So he shows creating, pretty straightforward worker that's interacting. Oh, I skipped over one neat thing. He's using the D# plus library, which kind of makes it a lot easier to interact with things. So the worker just responds to messages, responds to things. So like you see there, an on message created. And then, and he walks through those sorts of things. Then he goes through and hosts this. So there he's got the ping pong and responding to things. And so he shows also Dockerizing and throwing in Azure Container Instances. So pretty neat to be able to do that. And pretty neat how you can, host these sorts of worker services, and it's very light resource usage. And I built out a small one like this in the past, not Discord, actually, this was Slack, but our team was using Slack for communicating, and it like handled integration with that. It's pretty neat at what you can do with a bot. So.
Slack or Teams, John?
What's that?
Slack or Teams?
So I did Slack because this was a team that was migrating from Slack. And actually we had just a few weeks ago, or maybe a month ago, we had John Miller show off building Teams bots using Blazor. Right. Yep. So that's the next bot I would build. I wouldn't want to try that out. It looks pretty cool. Yep.
If folks aren't familiar with the worker template, it's just a fancy console app, right? Like, don't be scared of it. It's a really cool console app that uses the same underlying hosting library that ASP.NET Core uses from Microsoft extensions, so that you get DI and the config support and the logging. And then on top of that, we add support for easily hosting it on like as a Windows service, or obviously as a console app, which I said already, or as a like a daemon in Linux using something like systemd. And so we have first-class support for that. We have docs for it. If you boot it as a Windows service, it'll automatically write the event log like it should. It'll automatically coordinate with the Windows Service Manager, or you can just run it from the command line if that's what you want to stick it in a container and run it that way, right? So it's a very versatile template for doing these long-running console apps, basically. So check it out if you haven't looked at it.
It's nice how you describe it too, because it's got the simplicity of a console app, but all those things that you mentioned, like logging and DI and all that, if you start with a console app and wire that up, it's a bit of work. Every time I do it, it's like, I got to get to, I need this package. I need to set this up in my, my program bootstrapping code and stuff. So it is pretty nice to have this like all kind of set up.
Yeah. And it's just to separate it slightly more, I guess, is if you're building an interactive console app that you expect someone to like type like commands into, then there are other libraries that you should use for that, whether it's system.console or what's the really cool one, Fowler, that they're prototyping right now?
System.command line.
System.command line, and there's the dragon fruit one.
Dragon fruit,
yeah. Those are really designed for interactive command line, building interactive command line utilities, whereas this is more focused at long-running headless daemons, right? That's why it's a worker service template and the API that it comes with. So check it out if you haven't looked at either of those two things before.
Yeah. And as Niels calls out here, he's the one that wrote the post, but he commented, it's nice if you want to pull config from different sources, like
just like
depending on hosting. Yep. Very cool. Which a side note, I've got a post about. I did I created a function app that was connecting to SQL Server. So then I was like, well, I guess I'll use any framework, and because of that, I ended up doing a .NET 5 isolated model function. And all of a sudden I was like, oh, this is why it's cool. I can use all my configuration. It's like I get all the power of the ASP.NET Core stuff. That didn't totally click for me before, but being able to pull the configuration and having that it's a lot more than I would normally get just from the function app support. So anyways, all right. So this is cool from Andrea talking about permission-based security for ASP.NET Web APIs. And so he talks about his example here is, this is on the Auth0 blog. So he's showing how to configure those APIs on the Auth0 blog. He has a few callouts here that I thought were interesting. And I have mixed up in the past permissions and privileges. And his definition here is saying that the scoping is different. So I'm not sure if this is a security standard thing that I just never heard before, or if this is more kind of Auth0 focused. The way I'm reading this is that it is kind of the computer security way. When you say permission, that is within the scope of a resource, whereas a privilege is within the scope of the application. So it seems like, kind of a small distinction, but it is interesting to know and something I can use to.
It's funny because I'm going to further nuance what you just said, because I don't think what you just said gels with what you've got on the screen right now.
Okay. So
I'm reading it as a permission is specifically defined as an action that can be performed on a resource. It doesn't involve a person. It doesn't involve granting that permission to anyone. It is just the permission, like can read document, can upload file. That is a permission.
Okay, that makes so much
bound
more
to a resource of some type, like the file or the document or the app or whatever it might be. A privilege is a permission that has been granted or assigned to a user or an application, because you can have like system identities, right, or application level identities, and in order for them to be able to use resources that are protected by certain permissions. So I think that's just the nuance there that
it's funny. I keyed in on resource versus application, but that's not the distinction. The thing that you pointed out is the person, or is the person is the privilege level, and then the permission is not. So.
Yeah, the privilege is the granting of it to an identity, like whether that's a person or an application. It doesn't really, or a machine. It doesn't really, or a subnet, right? It could be anything that you decide, anything that you can address. But you give that thing the permission that you defined as, now you can read this resource or edit this resource, whatever it is.
Okay, I will speed up because I want to make sure I give David plenty of time. One other call out that he made in here that was interesting was he also talked about permissions versus scopes. So this is another one of those kind of digging in and talking about clarification. And so the thing he calls out there is the first party versus third party authentication scenarios. So pretty interesting. All right, Syed, so this is a blog about the web form support with Web Live Preview in Visual Studio 2022. So this is the new web forms designer. Yep. So, and this is specific in this release to web forms. He was on the show previously, and we talked about, potential other uses for it. But this is an area where it's, it pulls in, like, for instance, it gives a lot more accessibility support and things that we didn't have. So.
And the Web Live Preview technology isn't just used for this new web forms based sort of design view. It's also in this preview form. It's an extension you can install in VS today. It supports Razor files on ASP.NET MVC apps, not core. And then in Visual Studio 2022, we're integrating the Web Live Preview hot CSS reload capabilities into ASP.NET Core applications. And so that's a step beyond what you get with something like .NET Watch, or just hitting F5 in the browser or something like that. In that you can just edit the CSS file and not even save it in VS, and those changes will go over and be live, sort of diffed and applied to your application without you having to refresh the page or lose any state. And it literally is coming from the CSS file that you edit. They do that for Razor files as well for the old framework in the preview. And our hope is that with the hot reload support that we're introducing in .NET 6, and then beyond .NET 6, we'll get something similar for Razor and Blazor apps sometime after .NET 6. So you won't even have to save the file or do anything. You'll just make your changes in the .razor or .cshtml file, and after an appropriate idle and validity check, like those changes will just show up in your application. So there's some really interesting tech in the Web Live Preview stuff. But as you said, it's in this context, it's being applied to web forms apps.
Very cool. Yeah, this is amazing. It's like to be able to do that, and the productivity. Like I'm always a lot of time for more in-depth CSS stuff, I'm just using the browser tools and then copying my stuff over, and so being able to work directly in the source code is hot. Okay, here's just the blog post about that, Visual Studio 2022 Preview 2, and links to download and try that out. And then we have just the blog post about .NET 6. So this is .NET 6 Preview 6, and this is the kind of high-level one. And then this is the what's an ASP.NET Core. There's a ton of stuff in here. So I don't know, man. There's a lot. I'm excited about these minimal APIs. It's neat to see that. Also, a lot of stuff for Blazor. Like I've been learning more about web accessibility stuff lately and seeing some of these accessibility things that help kind of show the right way to build things. So a lot of stuff, and then just a lot of kind of tightening up the parameters. And things that for building controls and components. So, gosh, but just tons and tons of stuff in here. So
I might let the audience into a secret, which is interesting. Going back to the beginning of this show and like why we originally did it, just to give folks a sense of the timing involved with these releases. Y'all are reading the blog post about Preview 6, right? Which went out last week, like on Thursday or something.
Yep.
And we did the blog post. It's great. The same day, we literally shut down Preview 7.
Yeah.
So like Preview 7 moved into, and it was 2 days late. It moved into the next phase where we have to get sign off from the director of directors, like Fowler's boss, director of managers for engineering, to get bugs fixed in Preview 7. Like Preview 7 is done right now, and we're all working on RC1. And Preview 7 is being verified right now. Now, of course, anyone can get any of these builds any day from GitHub. And that's what's the great thing about the engineering setup that we have now with the open source stuff, thanks to the great work in the .NET engineering team, is that you can just go to like .NET/installer on github.com and grab the latest CI build for the SDK. And the SDK is what, like, and assuming that, I no guarantee how fresh any of the bits inside that are. You might get a really fresh compiler, but like an ASP.NET Core from 4 days ago because it hasn't flowed yet. Oh, some days you'll get everything that's an hour old because things are flowing really well because, infrastructure and issues happen and all that type of thing. But it's funny, like we still do these big blog posts, we do these monthly releases, and it's really important that we do it. But we do have folks who work on the edge and actually like pull down these daily builds. And then we have the really keen folks who are building it themselves, which even I don't typically do that and get my projects to do that. But yeah, Preview 6 is obviously out. Preview 7 is pretty much done, and you'll see it in a few weeks' time. And then if you want to get stuff that's we're working on right now for RC1, just go and download a daily installer. Make sure you use Visual Studio 2020 Preview. Otherwise you won't have a very good time. But you can do that and it'll work pretty well.
We have had requests in the past. A few people have said they would love to see how developers at Microsoft, like devs on the team, actually are.
We should do that show because it's fun. Well, okay. I would agree with you, Fowler, because Fowler knows, like back in ASP.NET Core 2, I was doing a little bit of coding in the repo. I contributed a few features. I wrote the original web host class that gave us the first higher level hosting stuff in 2. And then I basically like stopped coding in the repo for 2 releases. Like once I got Razor Pages done and I got that done, like I kind of stepped back and didn't do anything. And I only dove back into it like 4 weeks ago as part of the minimal API stuff and updating templates. So I'm like neck deep in this stuff now. And I had a whole bunch of folks help me. But I was like, man, we should really do a show that shows how to walk up to the ASP.NET Core repo from nothing and get it building.
And curse.
And now, because if you've done it recently, it's much easier to do again. If you haven't done it in a while, it can be a bit painful. And if you're doing it for the first time, we do have docs in the repo, but they're not always perfectly up to date. Or you might hit some snags. I would love to do that show, John.
Our repos are super unique. Like we basically live on the edge. So what happens is we get builds from the .NET runtime repository literally every day. So there's a constant flow of changes. which isn't the worst thing in the world, because if you don't pull, you won't see them. But if you fall behind, you will pull a massive amount of changes like every couple of days, like just huge change, right? We update the SDK, we update the runtime, we update all the dependencies all the time. So you're in this constant state of moving forward over and over and over. And it's not a thing you would typically do if you were deving in your own repo. You'd be on .NET 5 or 6 for like, I don't know, 2 years, 3 years. We literally update our .NET builds like every couple of days.
And even that doesn't really, I think, convey the magnitude. So what he means is that you rebase your branch that you're working in after a pull from main, and you have to run restore on the entire repo again. You probably need to run build on the entire repo again because the dependencies of the things that you're working on have likely changed.
And close VS.
And restore includes like installing a new .NET SDK sometimes. And then as Fowler just said, daily updates to Visual Studio. So first thing I do in the morning when I sit down typically is I run the Visual Studio installer. There's usually 2 updates for the 2 different channels of Visual Studio that are revving frequently. I apply those while I'm checking email. And then I go and download the latest build of the SDK, because that's not in Visual Studio yet. That doesn't get inserted until much later, so that I can use the latest full build of the SDK, which still doesn't represent what's latest in ASP.NET. So then you go to ASP.NET repo, you do the sync there, the restore in there, the build in there, and then if you're lucky, all that goes well, and then you're on the latest bits. And
by the time you finish step 10,
it's a new build coming
now
up.
step 1 is out of date.
Why do you think I do have a lovely, powerful computer? Because doing this on a laptop, or you do what Fowler does, you just carve out a little niche for yourself in the repo and hope that nothing else changes that breaks you. Yeah.
It's funny. I haven't done this for a while, but I experienced this the most in the past when I was working on build keynotes and conference keynotes. And I would work on the teams that would build out the demo apps. And all the parts are moving, and you need this special NuGet feed, and you need this special thing. And like it would be crazy, and you're running all these command line things and strong name hijacking and do whatever to make it work. And then by the day it goes live, everything is just file new project. You know what I mean? So all this stuff we've been like hacking through, it's like, it all just works.
It was much worse. I mean, like I remember when I first joined Microsoft, it was like just painful. Builds would take forever. There was a different.
It was 150 gigabyte enlistment on day 1.
Yeah, you couldn't build. You couldn't build your repo with like a normal command shell. You had to use this special command shell to build and stuff. It was.
Is that Razzle?
Razzle. It was very, very different. Yeah, it was just like a pain compared to now. So I am grateful.
Oh my gosh. Well, I am done with community links. I don't think it's worth like digging through this. This is a great post, and maybe we should do another show on this in the future. But so this last one, I'm just pointing this out because this is the slide deck that David's going to be showing, and this is included in that community links list that I already sent out. We'll send out again. I'm going to stop sharing. I'm going to pop over to David's desk.
Whoa.
Boom.
That was fast. Let me see. Should I show this? So I think I was here last time where I showed this is Kestrel's guts, as we call it. The transport layer, the connection layer, the HTTP connection layer, and the protocol layer. And I think last time we spoke about how we basically ended up with this model as a result of having 2 transports, libuv, when we first started ASP.NET Core, and then we added socket. So we needed a way to kind of plug in different transports. So this kind of evolved from need. So now we have this kind of pluggable model where you can actually plug components in at any point here. So if you want to change the transport, if you want to plug in your own fast socket transport, you can. If you want to plug in a different transport, like a name pipe transport or something else like that, you can here as well. What's funny, we actually have this transport written by the service bus team at Microsoft. They wrote a transport that uses, what's that thing called again? The reverse gateway thing.
YARP?
No. It is if you want to punch a hole through your firewall. So you basically, instead of having a monk
connect, the thingy connect.
Where's Clemens? He's gonna kill me. Instead of having to expose your computer to the internet, you basically punch a hole outwards into Azure.
Like
Azure Relay. Azure Relay. So Azure Relay, they built an ASP.NET Core server implementation that uses Azure Relay to accept connections from an outbound connection. So your app connects to Azure Relay, right?
Oh.
And then the client connects to Azure Relay, and they will bounce data from the incoming client to your application, and they decode the packets and turn it into an HTTP request from
That's cool.
in HPContext Core. Super cool. Actually, Sebastian actually ran our perf infrastructure on HPContext Core with that server implementation to run it behind like a secure network, right? Without having to expose that to the internet. Super cool. So the fact that you can replace the entire transport layer and do that without having to change the rest of HPContext Core was a goal. So these boxes represent logical layers of our stack.
Do you ever hear from customers that are doing that? Like, this is definitely something that we do internally, right? But
yep. So it's funny. There's internally like the .NET team, and then there's the customers that use our stuff that are more advanced. So for example, in the connection layer, we see customers parsing the bytes before it gets to the HTTP layer, doing mutations, doing rejections, doing super fast things, filtering, for example. And I thought that was super rare, but you wouldn't believe how many people do this. Like, how many of our big customers that have like reverse proxy style things, they slot into this component here and they do all kinds of crazy stuff to kind of get information about the connection and the host name before it goes to the HTTP layer.
wow.
So it's funny. I figured this layer would be like lightly used, but like we ended up building a component that can filter, that can give you the SSL handshake information before handing it off to Kestrel itself, because it was such a common ask that we had a bunch of teams actually like ask for that feature.
Wow.
And the fact that you could do it without having to like we didn't, when we made this layer, we made it for ourselves for layering, and we knew that it was useful for logging and that kind of stuff. But then as we kind of went forward, people ended up having to use it in their designs for more of this filtering stuff, which is pretty cool. So, and then once we get past that layer, we have one of these that implements the HTTP layer, and it handles HTTP 1, 2, and 3. And then we kind of unify the model, because HTTP 1, 2, and 3 are very different in how they're parsed. HTTP 1 is text, HTTP 2 and 3 are binary, HTTP 3 is over QUIC, HTTP 2 is over TCP. They're very different in how we handle like the bytes, the parsing, all that stuff. And that's kind of like abstracted in this layer, the connection layer. There's an HTTP 1, 2, 3 connection that are all different. But then at the very end of the day, you get a request object, and that is what we have as this base class called the HTTP protocol, which implements the feature collection, which is the core primitive of ASP.NET Core. So it splits off, and then it comes back into a single abstraction exposed to users. So when you do HTTP 2 and HTTP 3, you don't see the difference. You just get a request over and over and over. But under the covers, the server is doing different stuff to give you that request.
Two more questions just came in that look interesting. So one is this primarily TCP? I mean, is there other transports we're seeing?
So we only ship sockets. In the wild, there's name pipes. I think those are kind of the main ones we see people use. QUIC is a new one that we just did. So there will be a QUIC layer for this stuff too. And QUIC is a bit different because QUIC is a multiplex transport, but it has the same layers. So it's the same stack, just the transport isn't the same transport interface. It's a different interface because it has different features. But my gut is we'll see people do QUIC things directly on QUIC without having the HTTP on top.
Cool.
So there'll be a new gRPC.
gRPC will probably use HTTP 3 and not QUIC directly.
Right.
But Signaler,
something else will appear.
Signaler can definitely use QUIC directly without HTTP at all.
Because it's effectively just a slightly more structured UDP connection.
It's basically TCP, but you can, instead of having individual requests over one connection, you have individual streams. So streams are a first-class concept now in QUIC, where I can multiplex n things over one connection.
So it's like UDP merged with HTTP2 WebSockets all together somehow.
Yeah, think of it like a multiplex secure TCP. So it's TCP plus TLS without the headline blocking problems, and it's multiplexed.
Right.
So it has elements of HTTP2, UDP because it's UDP, TCP because it's stream-based.
And ultimately, because the bottom layer is UDP, it'll work everywhere effectively that you can punch UDP through.
Exactly, yeah. Which I don't know where that is.
I mean, it used to be if you used an old school HTTP proxy server, like my old enterprise I used to work in, we used to run little Python servers and stuff that could tunnel stuff over HTTP, right? The HTTP VPNs and things. But UDP, that's a different port usually.
Yes, a different port,
but not necessarily in this world with Quick and whatnot. They just allow it on the same port, right? Otherwise, your browser wouldn't connect to it.
It's funny. I think the way HTTP3 works is you send a request on HTTP2, and then the HTTP2 response says, I am actually hosting on HTTP3 on this, like, I think it's called the alt service header.
Mm-hmm.
So the server returns a header saying, hey, I'm also listening on this port HTTP2. You can send the next request to this new.
Unless you have an optimistic client, right? Like Chrome was.
Like
for a long time, where
Chrome is super aggressive.
Chrome, to try and reduce latency, especially for mobile clients, is how I understand it. For things like YouTube, it would go, let me just try and connect to HTTP 1.1, HTTP 2, and Quick all at the same time, with the assumption that Quick will come back first if it's supported, and then I'll just cancel the other two. And even if 2 comes back first, I'll try upgrading to Quick after that. Like they just,
Chromium, Edgeium, that class of browser is super aggressive. Like you type an address in the browser, you don't hit enter, and it's like hitting breakpoints on your server. You're like, I didn't hit enter yet.
So there's another question. Juan's asking, can middleware
be used separately?
What's the contract? I interpreted that
in
question
theory,
to mean like, what's the contract of the middleware? Could I plug it into something else or something?
You can. You would basically need a thing that can host the same model. So like as long as your transport layer could execute this kind of pipeline, it would work fine. Like if you look at my project Bedrock framework, it basically mimics this model, right? It's actually copied from Kestrel directly into this model. So in theory, yes, you can host it. It's not tied to the actual server.
So if Magma ever became a thing, your same connection middleware
can work on either.
Could theoretically work on Magma, assuming it wasn't using tunneling in to try and get a specific thing from the underlying transport.
Unless the transport is so different that it just wouldn't make sense. So for example, like when we did Quick, we tried to make the current transport abstraction work, but it was deemed to be too different. The multiplexing, but we had to fork the pipeline. So it's only if the transport cannot fit into this current model. If you don't have a connection abstraction, if you have something else, then it wouldn't fit.
Got it.
Yeah. All right. So Kestrel optimization. So Kestrel is our premier web server. It is extremely optimized. It is super efficient. We're very proud of it. It's multi-layered, but there are a couple of kind of high-level things that it does to kind of make the performance better all up. Buffer pooling is a thing you always hear about. You always hear pool buffers. We do it aggressively. We have a custom pool in Kestrel we're trying to get rid of because we want to not own it anymore, but that's a different topic. There's a pool there that pre-pins all the memory as it allocates memory. So since we're doing network IO, we end up having to interrupt with the OS APIs, which require pointers into memory, which require the actual address to do the actual IO. So we have to pin the memory to do the IO. Typically, when you pin, the GC can't move memory. So the technique typically in the past was you allocate huge chunks of memory and you pin it all up front and you tell the GC to leave it alone, essentially.
And was that to avoid fragmentation?
It was to avoid fragmentation.
Okay.
Turns out it doesn't always do that super well. Actually, we found a couple of dumps in the last, in the last year or so, where if you just happen to allocate with certain patterns, you could have 2 of our pin blocks between like a bunch of memory. And since we have the memory permanently pinned, it can never compact the space in between. So if you get lucky, you'll be fine. In .NET 5, we changed the allocations to allocate in the pin object heap, which is essentially a new space just for pin objects. So that I think will had improved the overall fragmentation there.
It's funny how much resource contention issues can just be solved by creating a new bucket.
until a bucket becomes
this rock is too big when I put it in this bucket, and it's just taking up all the room. I can't fit my little rocks in. We'll just create a special bucket for this rock, and then the other ones go near.
You could ask the question, "What happens to the pin object heap?" And then I'll just go like, "Yeah,
It's the same. It's just that it's not
Copyright.
colliding with the unpinned stuff anymore.
So what we learned, so what I learned, I didn't even know, like when you allocate statics, we allocate a giant object array that's pinned, right? And we store your statics in there. And it's pinned because the JIT can optimize not having to like figure out where it is. So it just hard codes the address to a static because it knows it's always pinned. It's never gonna move.
That makes sense.
And what happened was the statics were like being allocated in between our blocks. And it just caused this bad fragmentation. We were like, oops.
Interesting.
So we moved statics to the pin object heap in .NET 5 as well.
Wow.
There you go. Yeah. Yep. Who knew? I didn't know.
So I think we should at this point, it's worth just drawing a line under a part of what you said is that I think it's fair to say Kestrel and ASP.NET Core by extension, but Kestrel has driven a lot of improvements in .NET Core, .NET 5 Plus now. Like, from the network stack, like we moved from a custom networking layer, which we talked about last time, to a system.net.sockets. And as a part of doing so, we worked with the networking team to make improvements there. You're talking about buffering and pooling and
you see in
object heaps and
span is
although the structures to do the buffering and
Span,
pooling, they used to be custom in Kestrel, if I remember. And then a lot of that learning was taken, or they built better ones and we used theirs instead. And even things like the HTTP parser has gone through lots of iterations. The vectorization and the what's the name of those libraries? Intrinsics.
The vector intrinsics.
There's been a sort of a symbiotic relationship through a lot of these pieces as Kestrel would move ahead trying to push performance, and then the runtime would like catch up, and then Kestrel would replat on that. Pipelines, of course. How can I forget pipelines?
Pipeline span. It's funny. The parser started off as purely unsafe code and pointers.
Right.
So we had a goal to figure out how to get back to safe code while keeping the performance, and that took I think 3 versions.
Wow.
In 2.1, it was all pointers, all unsafe. You don't want to have unsafe like code in your server. Like there are couple where you don't want unsafe code. One is the server. We did it for performance. We were pretty sure it was fine. We hope for the most part, but now it's fully safe and it's actually faster. But that took a lot of work. The JIT team actually spent a ton of time looking at our scenarios, trying to optimize span for those scenarios. The goal was to make span as fast as pointers and safer, right? And we got there eventually.
Just to touch on what you mean by safe, because some people may not quite understand what you mean. Like .NET is a managed runtime and thus makes guarantees. And you may have heard the term type safety. It talks about type safety. Like you can't call a method on a type that doesn't exist. Like the runtime will go, no, you can't do that.
It won't. It will throw an exception.
It will throw an exception rather than crashing the process, right? And because it's managing the memory for you, it can move the location literally of a method from one part of memory to another, and it manages that for you. Now, you can turn off the guardrails and do unsafe things in .NET and say, no, I know what I'm doing. In this case, I am literally smarter than the runtime or the language or both together. And I know that this is safe even if you don't. So I'm going to enable unsafe operations so that I can avoid you doing bookkeeping and checks that are slow. That's what typically is meant by doing things that are unsafe. You typically don't do unsafe things just because runtime's wrong. And there's a very specific reason, because the runtime just doesn't, or the JIT doesn't have the logic in it yet. Or it's a very complicated computer science problem that I don't understand.
It's complex.
To safely do it with guarantees without checks. But a lot of those things have changed. Like even since like the last 3 or 4 years, the JIT is learning new stuff every release. The runtime is learning new stuff. The language has new primitives like spans, or the compiler is getting smarter. And we've got a fantastic community of performance interested folks who want to help the language advance. And then we've got like experiments like the native AOT stuff, which drives new ideas into the runtime, which gets rolled into core CLR as well. So it's an incredible amount of stuff that, as someone said, is the benefit hugely of dog fooding and having a really engaged community and a workload that we really want to work well, that we're pushing aggressively. In this case, the web workload till now that we've used to push the framework forward and the runtime forward.
Yeah, I guess as an example of the things that unsafe turns off is a very common one called bounce checks. So whenever you access an array index, the reason that throws an exception if you're out of bounds is because there's a check that's emitted by the JIT that says, well, JIT and the libraries, right? If you access this array out of bounds, if the length, if I is greater than length, then throw exception, right? That's better. That's a bounce check, but that costs every time you access the array, it costs that. So the JIT tries to eliminate bounce checks if it knows you're within the range. So if you do a for loop and the JIT can recognize the length property and it knows the length is 5 and you're at element 0 to 4, the JIT can safely remove the bounce check. So the trick is you have to write code that the JIT can understand to remove bounce checks. So a lot of the work in span was around those things. Like arrays are insanely optimized. Like, it's funny, it took us super long to get back array performance with spans. Like spans are like super cool, can represent stack memory, heap memory, whatever. Arrays are unsafe, but arrays are hella optimized, like insanely optimized. So all the work in span was, well, not all of it, a bunch of the work in span was getting the perf back to what arrays are like. And people still find bugs every now and then and say, you know, array is 10x faster than spans in this one case. If I do a loop and I change this to be a length over here and the JIT can't follow it, and it's like, oh wow, we should fix that too. Wow. So yeah, the parser is in a state where, it's funny though, I would say we were at a point, we were in a state once where if you touched the parser and you didn't really understand what was happening, you could regress performance by like, you change a pattern, the pattern is very specific, don't change the pattern, right? That's getting better. The JIT is beginning to understand more patterns now, so it's less of a maintenance burden. And we used to comments.
we would, because we would do tricks, or people would send us tricks saying, I changed the order of these like operations, or I put this special offset in a thing because I know the JIT can recognize that pattern. Or if I do it this way, the JIT avoids a bounce check, whatever it might be. And it doesn't sound like much, but the thing is, in high throughput, adding a bounce check could suddenly result in enough CPU cycle time spinning that you get flushed from a cache line, or you get scheduled preemptively to a different core, or like, or you know, you lose the magic, right? So it's funny how in our community we always have these arguments about stuff that's too magic or not. Like everyone has heard that before when we talk about framework design and APIs. Oh, it feels like too much magic. I'm going to tell you, people, .NET is nothing but magic. That's the entire point of the runtime and the language, is so that you don't have to write things in assembly or even C or C++ and manage your own memory and call system APIs that are different. The whole point is so you don't have to worry about that. You deal with objects, you deal with values, you call methods, you don't know where they are, you don't have to dereference them. That it's all magic, right? And the magic gets better release to release to release.
There was, I think the best hack I saw that we learned trying to optimize code like this was like, if you write to the array backwards, if you have like, let's say 4 of these, right? And typically you have like bytes. So like, imagine it wasn't infinite, it was bytes. And I want to write to indices 0 to 4, or if I went 0, 1, 2, 3, and I wrote numbers, if I did like x of 0 equals like 1, etc., the JIT adds a bounce check, making sure that 0 is less than length 4, right? But if I write 3 first and I count down, the JIT just needs one bounce check at the first one. Then it knows that 2 is less than 3 and 1 is less than 2. I remember changing our code to do this, and it was like, maybe we're crazy. Maybe this is like, this is insane. But it was funny. Like I think we have this code all over the place now, and I think it got better in .NET 5 maybe, so we can undo it. So we keep having to like write code and then undo it as the JIT gets better.
Well, there was a thing for a while within Kestrel where there's a big code generator, right?
There still is.
Yes. The headers.
This one right here, look, the headers. The header dictionary is actually insane. So when we designed the header, we wanted headers to be super untyped and loose. So it represented what the actual HTTP request had. It was a string name and a string array of values. We didn't want to have to allocate an array for every header value, because rarely do headers have more than one value. So we have this type called string values, which is a string or string array type. So as data comes in from the internet or the client, we parse the bytes, and we know that this extent of bytes is a header key. It could be content length. It could be like keep alive. Could be anything, right?
Mhm.
We don't want to allocate a string for that. We know the byte pattern for those strings, so we just do a fast comparison, and we basically co-generate all the comparisons for a given byte array. We know ahead of time, like, if does this thing match this bytes. So we match on length first, and then we match on like some kind of suffix, and then we do some kind of like crazy matching to make it fast. And then we know we don't have to allocate a key. We just know the index of the content length header is like number 4.
Would you phrase that? I'm not a comp sci person, but is that like a custom tree type of thing? Like you have or is it just like a multi-phase?
It's like a multi-phase trie where we first compare on length, and then we compare on unique prefix.
And it's all about narrowing the amount of things to look for, right?
Yeah, it's a TRIE.
Okay.
Oh,
yeah, try. So we do it for the header key comparison. So we don't actually allocate header names that are known. We have a bunch of known header names, and we don't allocate anything there. And then for values, we do allocate. But then Ben Adams, one of our performance like gods on .NET, we can pool header values across the same connection. So on HTTP 1.1, you have one connection for n requests, right? Mm-hmm. Over those n requests, we can share the values if they're the same.
Right.
Oh, wow. Because
otherwise we have to allocate the string because the bytes are coming in dynamically off the wire.
Yeah.
And so we typically at some point you'd convert that into a string, and that results in it being allocated. But instead of doing that, you go, well, I know these bytes are the same as the ones already read for this same client. So just point them basically at that string.
I gotta say, I've seen some production workloads recently, and I've seen some headers that are like massive. I couldn't even believe how big they were. Like 16 kilobyte auth headers. It's like,
wow. Okay.
So yeah. So it's funny. I actually had to get that team to turn the pooling off because it was hurting their memory. Because the headers ended up in Gen 2 when typically they'd be in Gen 0 because it's a 16 kilobyte header that would go per request. And since we were pooling it across the connections, it was ending up in Gen 2, and it was like, oops, let's just turn that off for these connections.
John, can you highlight Juan's recent comment? I'd like Fowler to talk about that because we talk about, you'll hear us say, we don't allocate quite a few times. It actually means something different in different contexts.
Yeah.
And sometimes it literally means we truly don't allocate at all from app startup for this thing. Other times it means other things, doesn't it, Fowler?
Yeah, so for headers specifically, we literally have a string constant. So string constants are not they're basically bytes inside of the binary. They're intern. They're like, you have a single object representing that string constant. And for known header keys, we never allocate a value beyond the constant that's in the binary for those known headers.
Right.
And then I guess don't allocate can mean a couple of things like Damian said. For the most part, what we mean is, if I say literally don't allocate, it's that constant case. If I say we don't allocate, it's normally amortized over some period where, for example, if we don't allocate per request, we do allocate per request. We just happen to reuse all the memory across requests. So we do have an allocation, a set of allocations that happen per request, but then they're amortized over the connection.
Right.
So if you have multiple requests over that connection, you won't see any new allocations.
Right.
Right. So you'll get one bunch, and then you'll see you won't see any more per request.
And so you can literally, in certain tests, get to a steady state where you literally do not allocate any more memory. No matter you send 10 billion more requests, no more memory gets allocated because the things that those requests were set up to do in the application is so minimal or only touches parts of the stack that are non-allocating once they've been set up on the connection, like a lot of our performance tests are. That you get your 100 meg allocated at app startup when the first 100 connections comes in for the load test, and then that's it. No more memory ever gets allocated. GC never has to run, and like everything basically is just pure compute after that.
So for example, if you wrote a middleware that wrote to the response hello world in ASP.NET Core that returned the task to the middleware pipeline, and you run it on Kestrel in a tight loop, you would see no allocations. You would see the allocation of the connection itself. You would see all the state for a connection. But if you hit it with a benchmark tool, you would just see all the allocations that were per connection. And if you actually look at the tools that can track allocations, you can look at how many things were allocated and how many requests you sent. And typically what you do is you send 1,000 requests, and you look for things on the order of 1,000 to see what things were allocated per request, right? If you were to run a performance tool on Kestrel, you would probably see a couple of connection allocations, but it wouldn't allocate anything per request. We basically turned that. Yeah.
Fixed load tests, like where you have a fixed amount of load, is a really easy cheats way of finding stuff that is being allocated for that lifetime, right? I'm going to put 100 connections and they're all going to do 1,000 requests each. And that's your test. You run it with a memory profiler and then you just look at the object counts afterwards. It's like, oh, I got 100 of these and I've got 10,000 of those and I've got 100 million of those. Oops, I've probably done something wrong on that one, right?
It took us to .NET 3.0 to nuke the last set of allocations. The last set were like thread pool dispatches. And there were so many. Like we allocate a small object per dispatch, and they're all reused now. It's absolutely incredible.
So like even things like routing, like doesn't our routing, our hello world routing test doesn't allocate.
Nope.
Once the routes are set up in the system and the tree is built, you like every request doesn't allocate something to look up the route. Like it's literally no memory.
You need to have once you have patterns, it'll allocate a dictionary, which is funny because like the dictionary has to exist because you want to call you want to actually access the route values in the future.
Right.
You could imagine if we had a system that was declarative and we knew that you were going to parse into an integer, the routing system could basically say, I'm not going to store it. I'm going to parse it in line and just avoid the allocation completely, right? So you parse the route parameter, and as you were going to like store it, you would say, okay, I'm actually going to call this method, so I won't bother storing it in route values.
Oh,
so you can that is a dictionary altogether.
Yeah, you put it on the stack, and then it gets passed directly to the next caller that you're dispatching to, like your action method. Which let me be clear, that almost never could happen in MVC because there's so many layers in between your action method and the route. But in like raw routing to middleware, that's
you could
yeah, interesting.
So we pulled the HPContext objects. That was a super fun change we did in 3.0.
That was scary.
HPContext is like what we call a God object. It is by design a poorly designed from a solid standpoint. Like it does more than one thing. It has all these properties that kind of reaches out into the whole system. It's a convenience layer. We pulled these in .NET 3 from 3 on. It caused some interesting bugs where people would kind of hold on to the HPContext and pass the request lifetime, touch things, and you would think that wouldn't be a bad thing in .NET because it's managed, right? And you have a GC, and that tracks lifetime. The moment you do pooling is the moment you're saying, I am smarter than the GC, and we're not. We're absolutely not smarter than the GC, but we thought we were. So we say, we're smarter than GC. We can do a better job. Let us pool. We know when the request is over. But it turns out like people lie all the time, right? Like they say, I'm done the request, but it turns out they're still holding on to some object in the closure somewhere. It's like, oh, it's hanging on. So we had this cool bug where people would access the next request in their code because we reused the same object. And the first time we saw it, I remember going like, oh no.
Cross the streams.
Maybe.
To be clear, there's a really bad version of this bug, and there's this version of the bug he's talking about, as I understand it, right? So this version of the bug is bad in the sense that it'll probably cause exceptions for you. The really bad version is that you can leak things you shouldn't leak across different security contexts, right? Different users and things. But no one was brave enough, I think, to suggest that we would ever reuse contexts across connections because the connection is the boundary of the security principle, right?
Yeah, exactly. So we actually had a bug like that in 2.1 where the execution context was being reused across requests on the same connection, but requests were coming from the out of process ASP.NET Core IIS server. So people were getting the wrong like Windows principle across requests. It's not a thing you would experience. I think people typically don't mess with the execution context in .NET directly. You typically get the current principle and you assume it's correct because it was set up correctly by IIS. We weren't doing it properly in Kestrel back for that scenario, and it was just like horrific. What could happen?
Well, that's a bit of a segue to the next slide. where you
Yeah,
talk about
booleans.
the Windows HttpSys, right?
Oh yeah, HttpSys. Okay, so we spoke about, I think, I don't know, in part 2, we spoke about how we support multiple servers. I think, like, let me find that slide here. There's Kestrel, HttpSys, IIS, test server, and star other, right? HPContext is a kernel mode driver in Windows. That means it's actually in the kernel. It comes with Windows. It's a part of Windows. It's part of the guts. I think sys is a typical extension for drivers. HTTP, because like it's the actual HTTP protocol, is actually written in there. It was built, I assume, for IIS. I wasn't there. I wasn't here when it was built, but my assumption is we want to put a web server in the OS, in Windows Server, and to do that, to put it in the OS, it has to be on by default. And they want it in the kernel to take advantage of some of the benefits of being in the kernel, which we'll talk about. So there's a thing in Windows built in that does HTTP on every Windows version, and it's what IIS is built on top of. And we have our own managed wrapper on top of it. If you've ever used HTTP Listener in .NET Framework, it's the same component. HTTP Listener directly p-invokes into Windows, into these APIs to create an HttpSys server. It's a bunch of p-invokes for handling requests at the OS level. It has a bunch of unique features that you may want to use in ASP.NET. So imagine the reason IIS works on one machine where you can kind of share multiple applications on the same port 80 that are differentiated by path prefix. I can have site 1, site 2, site 3 on port 80, all working in parallel on IIS, and that works fine. It's because HPContext supports port sharing natively. So when you configure HPContext and you configure a process, you say, I want to listen on this prefix. You don't say you don't exactly say, I want to listen on this like address and port. You say, I want to listen to this like URL prefix, and it can contain a path of any depth. And the kernel will basically send requests from the listener in the kernel to the right process, assuming you have permission. So it does all the work required to kind of do port sharing across process in a very efficient way. So that's why we have a bunch of people that still use HPContext directly in general. Request queue creation, HPContext has these things called request queues. So you create a request queue, requests come into the queue, you bind the request queue to a prefix, to a URL and a path and a port, and requests get handled and come into that queue, and you the queue from that queue, and then we serve requests in ASP.NET Core. So we grab requests from the queue and put it on the thread pool, and we execute your ASP.NET Core pipeline. So if I was going to draw the architecture, which would be much smaller, there'd be like request queue and thread pool queue. So we go from one to the other to execute your code. Talking about a couple of specific features of HPContext that don't exist on other servers, kernel mode caching is one of them. You can tell HPContext to cache this response using the cache headers. Like you assume this response is cacheable because it has all the right headers. And HPContext will never enter user mode. It will serve the request directly from the kernel. So it never has to go all the way through the networking stack all the way back. It will just serve it from the net, just directly. Should
we talk about the difference between user mode and kernel mode a little bit? I mean, we have a variety of people.
So kernel mode is, think of it like there's this boundary in every OS. There's like 2 layers. There's more than 2, but there's 2 layers. There's where your code runs and applications run, and there's the kernel. The kernel has to interface with hardware. The kernel protects your apps and your code from the hardware. The hardware is like doing all the crazy stuff and talking to all the devices directly, and it's at a place where, when you get a blue screen, the blue screen is the equivalent of a normal crash in kernel mode. You don't want apps to blue screen like crazy, right? And they're different. There are different levels of security at the OS layer. For example, in the kernel layer, you can see all the apps in a single space. In user mode, every app has their own security context. So think of it like there's just different layers of security and access. And the kernel mode drivers let the OS kind of cheat and can kind of do everything. It's kind of like master mode, right? I can kind of see everything. It's God mode, right?
Yeah.
You're in the kernel. And user mode is where your app lives and is protected.
And then those transitions between kernel and user mode are very expensive, right?
Right.
Yes, they are. Yeah.
You basically think of them as thunking, right? Like it's like you have to set up a bunch of bookkeeping, do a dispatch across this layer, have to wait for the thing. Yeah, like it's
preparing the right context, right? So for going both directions. So whenever the kernel has to call back into you, it has to know your process, your thread, your whatever, and I have to kind of set up all the context to kind of change from where it is, right? So it's funny. It sounds like magic. At the core of it is just some structures that would look normal to you if you were like a normal programmer.
It's like a big Excel spreadsheet that someone that someone is editing in real time every time they want to perform something. And it's like, as Fowler just said, like it has to figure out where it is and then like pause that so it can call you. Like that literally means it's go, okay, I've got all this information in the CPU right now. I have to get that off the CPU, put it somewhere I can get back to it later. So I basically store the state, right? State machine or whatever it is, pull it out of the registers and things. And then I'll set up the new context, which is just a fancy word for some more data, like some data, a memory structure. And then I'll tell the CPU some things, ask you for more things. And it's just basically that bookkeeping over and over and over and over again. Yep.
So so essentially, when we do networking, when we write dotnet applications, we're not in the kernel mode, right? And we have to transition between kernel and user to do things like pinvokes or syscalls or any call into the operating system, right? And that has to return to us and give us the right data for our specific call to that API. So yeah, that's kind of the whirlwind tour of like the high level difference between kernel and the other mode. Send file is a unique capability of it's actually available at the socket level. And the feature here is if I want to send a file as a response to a request, so someone sends a request to me and I want to serve a file, it could be JavaScript, CSS, whatever file is required. Typically what happens in Kestrel, for example, is the request comes into our code and we have to open a file in the kernel and then copy the bytes from kernel mode through our code back into kernel mode, right? So it goes from file into our code, copying the bytes into the response. That's 2 hops, right? What if I could just say, hey, kernel, can you send this file to the response without ever having to like change modes? Don't hop at all. Just blit this file over the wire. So it has this feature called send file, and send file can basically blit the file to the response without having to change modes, right? It just does it from kernel mode directly.
Because kernel mode can access and read those files, and it can
cheat
directly.
It's God mode, right?
So rather than the user mode thing, reading the file bytes up into user mode, processing just to send it straight back down again, you can just say, no, you just do it. Send this file. Here's the path. Off you go.
It's copy that file to this response.
Right.
Two kernel objects that can talk. This feature exists for sockets. We can't use it because if you do SSL in user mode, I can't just say sockets, can you do the needful and copy stuff? Because it would basically avoid the SSL layer. So you basically need to do everything in kernel or everything in the other mode to get the whole thing to work properly. You can't kind of have half and half. So that's kind of why it is the way it is right now. Windows Auth isn't a unique feature of HPContext. I believe we actually have this feature now in Kestrel, but it is built into HttpSys today. But I believe we do have a new middleware in ASP.NET Core that can work on Kestrel to do Kerberos, not NTLM though. NTLM is I think considered like, where's Barry? It's considered never use this.
Yeah, it's
legacy.
It's the old one.
And request queue delegation is a brand new feature in .NET 5, where this is interesting. Think of it like a fast reverse proxy. I have 2 HPContext processes on the same machine. Typically, what you have to do if you want to make a reverse proxy on the same machine, you could open a name pipe, you could open an HTTP channel between the front end and back end server, and send requests over that way via HTTP. But you have to reserialize state and send it over HTTP and get it on the other server, et cetera, et cetera. With request queue delegation, it's interesting. the kernel sets up a shared queue in kernel mode between the two processes, and I can basically transfer requests from one queue to the other queue without having to reserialize the state. So think of it like a fast way to forward a request to a different process on the same machine.
Is it a bit like fork on Linux? Like people talk about forking processes. I mean, I know the process itself gets forked, but like in node clustering, I think you fork, and then the front one is the one that forwards the requests at the node level.
It's copy on, right? Yeah. This is a bit. This is
lower
a bit,
level, right?
It's faster because you never have to reserialize the request. It's literally shared memory. So the kernel can cheat, right? The kernel can just say, I'm going to send this request to this other queue over there in kernel mode. I have these two structures. I'm going to put this request from this one over there.
I see.
And then jump from kernel. And then you can just like process request that way. So all you do is you configure your request queue to have data sent to it. And then I can kind of forward your request without having to like.
So HttpSys has had that feature for a long time, right?
No.
No? Okay. So the Web Garden feature in IIS did this differently. Didn't do this. Oh, interesting. Okay.
Yeah. This is because Web Gardens let you set up a bunch of processes, I believe,
on the same binding.
On the same binding.
Yeah.
And then I believe that by default would just round robin.
Just round robins. Okay.
This one is I can read the request data in one queue. I can actually dequeue it.
Got it.
I can dequeue from my current queue, read the headers, read a bunch of things, and then I can say forward to this other queue.
Understood.
And it will transfer. You can't touch the body because the body once touch the body is over, but you can actually delegate the request across process on the fly.
That's super interesting in the concept. You know, you could think of it in the context of a proxy server or a front end proxy of some sort, where you could have a high priority process for certain requests and a lower one for others. So like one that has more memory or containers or like some orchestration thing. Like you could do something interesting, perhaps with that. But I think what's it mostly used for today? Like, why did we add this feature?
I could. Why did we add it?
Yeah.
Initially.
Yeah. Someone asked us.
We asked for it. We were thinking of using it on for ANCM.
Okay.
That was the impetus of doing this. There are a couple of teams that are building on top of it now at Microsoft.
Okay.
So we have it built into ASP.NET 5.0 as a result. Yeah.
Okay.
Super cool.
It seems like it's too high of a level of abstraction, but I almost like that whole delegation. You could almost see something like that in like a microservice context or something, you know?
Yeah. Yeah, exactly.
Yeah. I mean, you could imagine. Yeah, I don't know. Kubernetes has one built in, right? Like that comes with a request, or maybe a connection.
Ingress.
Connection, ingress. Right?
Connection level, not ingress by default.
Yeah, connection level, right.
Yeah.
Not
but it's done in some super hacky way.
Right. Okay.
Wow.
DQ from request queue. Yeah, this is pretty boring. The code looks gnarly, but the design is actually pretty simple because most of the code is deep in HPContext. And what's important is to know is that we actually do not get information about the transport layer here. You can't get TCP. Well, I don't say can't. In general, some things aren't exposed to you because you have been given this request abstraction. So you get a queue of requests. You don't really get the information about the TCP or anything under the covers. And HPContext does handle HTTP 1, 2, and 3 as well. And the model itself doesn't change. You get a request queue. That's all the same. And then we turn around and dispatch to the thread pool as a result.
So this applies to anything hosted on Windows architecture, including, I'm guessing, then like Azure websites and stuff?
Ooh, that's a good question. Yeah. Right. So Azure websites on Windows uses IIS, and IIS is all HttpSys.
Wow. Okay.
Yeah. Yep. It's funny. I had to read the IIS code recently to debug something. And I had to read how they interact with HTTpSys, and everything clicked. It was like, oh, that's how it works. Super cool. Okay, number IIS. So IIS is the last server. It's the one that everyone uses. This is how you use HTTpSys indirectly on most of your deployments. If you've been doing .NET before, I guess 5 years ago, before we had Kestrel. You hear us say ANCM. ANCM stands for the ASP.NET Core module. It is the IIS module that we wrote in .NET Core a couple of years ago, 5 years ago now. There's 2 modes to it. When we first started off, there was only 1 mode. The goal was to have a single web server, Kestrel, and that was going to be the one that ruled them all. And it was beautiful, but then it turned out to be a bunch of problems with doing this, what we call the out of process mode now. So there's 2 modes. There's in process, where the .NET application runs in the worker process. So dub3, dub-p, that process. It runs in that process itself. And then out of process, there's a dub3, dub-p, and a .NET process that we forward request to. Obviously, in proc is much faster. There's no process hop to do HTTP. We don't support running multiple applications in a single worker process. I think this was supported on System Web and ASP.NET of old. So you can actually run more than one application in the same process, because we had app domain isolation that's gone in .NET Core. So we only let you run a single .NET Core application within an app pool.
That's what app pools were. Yeah, exactly.
Right, exactly. Our module does not interact with the entire IIS pipeline. If you are familiar with ASP.NET and not ASP.NET Core, if you're familiar with like the integrated pipeline, begin requests, HTTP modules, ASP.NET Core ASP.NET System Web used to actually interleave manage code, so you can handle every single IIS event in C#. In ASP.NET Core, that is not possible. We run in a single module event, I think execute request handler, and you don't get to hook the pipeline. You can run side by side with System Web modules, because they're both IIS modules, so you can interleave, but you don't get the same amount of control. You can't like handle authenticate requests in ASP.NET Core. You can't handle post resolve request cache. Like there's like 50 events, right? You get to run in one handler, and there's no way to like jump out of our code into the pipeline as well. So once you enter ASP.NET Core, it will own the response. In System Web, you could do crazy stuff where you could System Web essentially gave you a way to write managed modules. So it tried to expose the full behavior of IIS in C#. So you could like in one event kind of say, I'm going to handle the request, and in the second event say, you know what, I was wrong. I'm going to back out, and you should resume the pipeline. That control is lost in ASP.NET Core. We give you access to the IIS HttpContext essentially, and that's about it. And then the overall design is that there are 2 shims. So when we wrote the new ASP.NET Core module, ANCM, the goal was to have a model that we would rarely have to update any global install. We wanted to be able to run and update the module without having to install a new MSI, right? That was the mindset. We wanted a package to be able to be installed, and you could update the IIS module. Turns out IIS doesn't support, who would have thought, IIS does not support local modules like on your machine. You have to install it into the global folder in C Windows, like with like admin privileges. So that was a hard thing to swallow. So we broke up the design into this model which we call the shim. So the native shim exists globally. It's a thing you install. It's the ASP.NET Core hosting bundle. Installs the shim globally. And the shim implements the IIS interface for modules. So whenever you want to write an IIS module in C++, you have to write a piece of code, compile it as a shared library, a DLL, and install it globally on the machine, and then put in application host config. Here's the module. Here's the path to the DLL, and it has a certain shape, and it all works fine. So our shim does that, and then our shim does magic to load from the right location, either the shared framework or your application path or wherever, another shim that is native called the request handler, and it could be in proc or out of proc. That thing will initialize the CLR, it will host the CLR, boot up the entire thing, run main, and then it'll boot into ASP.NET Core's typical program CS logic. The implementation of the IIS iServer, what it does is it basically wires up all the callbacks required to handle requests. in the in-process request handler shim. And then from then on, requests that come from IIS will get routed to ASP.NET Core via the shim. And then the goal of the IIS server implementation in C# is to marshal request information from native to C# and back. So when you call response.write, that buffers a bunch of data, and then we'll do a call into one of our P invokes in process request handler to write to IIS. So this middle component has a bunch of P invoke, DLL import layer exports, where we essentially say, here are all the things you can do with IIS from this code. You can write to the response, you can read headers, you can read all these variables, and then we expose the feature collection, and the feature collection is implemented over those primitives. So when you call response.write, it does the right thing. When you try to do WebSockets or any other interaction, it does the right thing. It also has to manage the lifetimes properly, because we're doing some crazy interop here. So whenever the request ends, we have to make sure that you don't touch it, so you don't access some piece of code that will crash your process in the wrong time. So there's a lot of code in these two layers to manage that. Also, with this design, what's interesting is whenever we want to deploy a new version, we do this trick where, remember app offline from the olden days?
Oh yeah,
app offline has to be recognized at this layer, the shim layer, and at the in-process layer. The shim layer, because if you have an app offline, we don't even start this half of the universe, right? App offline basically says you can deploy a new build of your application, and we will not load it until it's gone. So app offline gets read here, and it says, I won't even boot your CLR until you tell me app offline is gone. So where components are depends on what needs to read them. If you need to basically not have .NET code run, you need to basically do it in the shim. The shim is a thing that runs before any code in .NET runs. And then the handler is where we actually interrupt between .NET and C#. Sorry. No, C# and native.
Right.
But that code actually boots up .NET, so it's too late there. So if you want code to run before .NET loads, it has to be in the shim. And
But it means that we can deploy a new version of .NET.
Exactly.
Like .NET 11 can come out with new hosting native code and all wonderful new features.
Exactly.
And in theory, we only have to update. We don't need to do an admin install on the server, because you can literally deploy that middle box with your app in your bin folder.
Exactly. And what's important is for self-contained deployments, these components are not installed globally. These components are local in your app folder, right?
That was the big innovation here with regards to how we hosted on IIS. And that was, we avoided it for a few releases because it was all, I mean, I think we kind of had the idea, but it was like, And so we just did it like the normal model. No, it's an admin install. And we just keep getting the feedback. And frankly, it was also a pain in the butt for the Azure App Service team, because we wanted to be able to have them very quickly stand up new versions of .NET. But if you're running a global fleet of hundreds of thousands of servers, it can be, and you say, just run this installer as an admin. And all of them, they kind of look at you, the doors closed before you even got to the end of that sentence, right? So we had to do something better.
Yep. So I think we've got one more slide left on this IIS group, and that's just the IIS architecture out of process. And we're kind of late in the day, so maybe we'll wrap up here and then jump back in after this one.
Yeah, sounds good. So the last piece is the out of process design. Same overall design, where there is a shim still. The shim will load either the out of process module or the improc handler. That's based on a switch in web config. So if you have a config, I think there's a mode for out of proc versus improc. If you mark your app as out of process, the shim will load the out of proc handler, which is, I believe, installed globally, because we don't really update this thing super often. Don't use it. And if you look at this process, is .3.p, the worker process for IIS, and over here is Kestrel. So what ends up happening is there are HTTP requests being made for every single request, where we translate the incoming request and we send request to the .NET Core process using WinHTTP, which is a kernel mode HTTP client I didn't mention before. The same team owns both, which is good. So Windows has a built-in HTTP client and HTTP server. There you go. And it uses the HTTP client in Windows to make requests to your application. So pretty simple, but the perf hit is massive. I think in process is 4 times faster than the other process. So it's a significant perf hit to want to use the other process mode. But the benefit is you can run more than one process in the same app pool, even though it's kind of a light because you're not in the app pool, you're kind of on the side of the app pool. You still have your other process there. IIS will manage the launching of this process, the port selection. It does all that for you on the fly. But yeah, other proc is a mode that we want to deprecate, so stop using it. Thanks.
So to wrap up a bit, there's one question from Chris. What does the .NET web hosting bundle install?
Ooh, God, I remember when we first put that installer together.
It installs this, the shim, the improc handler, and the shim and the other part handler. The 2 handlers.
And .NET itself.
Oh yeah, you're right. It actually can. Yeah, you're right.
That's why it's a bundle.
Yeah, it has both. It has both things. It has the shim. Sorry, it has the IIS support and .NET.
Yeah, and so it does not have the SDK. It only has the .NET runtime, and it has both the 32-bit and the 64-bit version of the runtime. That's also something unique about the web hosting installer, because IIS is a dual bitness web server in Windows, because Windows Server still supports 32-bit processors, even if you're on a 64-bit hardware.
Hold on.
And so it installs both. And there are 2 versions of every native module in this diagram that Fowler's talking about. There is a 32-bit version and a 64-bit version, and they live in different paths. You have to make sure you load the right one for the right application. And that's one of the other challenges with the in-proc hosting, is that .NET is usually any kind of like, it depends. And so you still have to load the right thing though. And default I think is still, I know in Azure websites for Windows, I think it defaults to 32-bit processors, and you choose 64-bit if you want it. But on Windows, I think it defaults to 64-bit, and you have to set it to 32-bit if you want it.
Yep, that's right.
So it's the opposite. And so we had to do all the work to make that work. So the bundle installs 32-bit and 64-bit ASP.NET Core module for IIS, 32-bit and 64-bit .NET host, so .NET EXE, and the .NET runtimes and the ASP.NET Core shared frameworks that run on that. That's what you get, all that stuff in the hosting bundle.
But I assume it does not put the 32-bit .NET on the path. Probably not.
No. But so you can get yourself in a pickle though.
One of the path.
And people do, because they don't realize that the runtime is installed. And so they go and get the 32-bit runtime installer, install that, and that brings in the 32-bit host, which then is the last one installed. So it ends up on the path last. And then they try and run .NET EXE just from the command line normally, and they get the 32-bit one. So in IIS, it's all fine, because in IIS, we do the logic to pick the right thing, right? But it can muck you up if you're on like a dev machine, but you're running full IIS and you get the wrong thing on the path. So you do have to be careful with the command line, because you typically only have one global thing on the path, and it's native, so it'll be one bitness.
Cool. All right, I'll do 2 last things. So question on which version. This is at least
old
3.1, but
2.2 I think was the first version.
2.2 was it? Yeah, 2.2, which is out of support. So 3.1 is the currently supported version, the lowest one that has that.
Okay, and we'll end one with a slight controversial thing. But is IIS still a thing? And
whoa! Shots fired. Yeah,
I know. So one thing that we already covered is definitely like Azure App Service. That's all running.
The Windows version of it.
The Windows version.
They have a Linux version, obviously, as well.
Yeah. But then, I mean, there's a lot of different, there are some big companies that run a lot of stuff on IIS.
You had Nick on here a couple of weeks ago, didn't you?
Yeah.
So, Stack Overflow.
Big companies like Microsoft, by the way.
Yeah. I mean, but yes, it is a mature technology. It is a mature web server that's been around since before I had written any .NET code or even knew .NET existed. It is around. IIS has been around longer than .NET, right? It was there for ASP Classic. And so, it's been around a long time, but because of that, it's everywhere. Like it's
also, I mean, it's super highly optimized, and it's something that can be administered like it does not take
Yeah.
decades to become able to administer it.
It's also a jack of all trades. Like, because
Yeah.
it's been around for so long and it's designed as a generic web server, there's a plugin for everything, from, if it's not from Microsoft, then from a third-party company, or you can write a module for it. So, like Apache in that way. It's been around for as long as that type of thing. Now, that said, there is something we can announce about .NET 6 that perhaps I'm not sure we've shouted very loudly yet, that for .NET 6, the default launch profile for new .NET 6 apps in Visual Studio is now Kestrel instead of IIS Express. And we made that change just in this release. This is the release where we're going to do that. And so there you go. If you wonder why when you create a new .NET 6 app in Visual Studio 2022 and you control F5 or F5, you don't see IIS Express tray appear or whatever, it's because we changed the default to Kestrel. You can set it back to IIS Express. It'll still work just fine. It's still there, but we just chose the other one.
Awesome. Okay, so I think we'll wrap here. Can you flip to the next slide just to give a preview of coming attractions?
Ooh.
So we're moving on. This, we talked about like hosting models. We talked a lot about the IIS like interfaces and stuff, and then we move on to request processing next time.
Oh yeah, middleware.
Yep, middleware. A lot of good stuff. So
there you go, sneak peek.
Wonderful. Okay. This is cool. I hope some people were able to, there's nice C# Fritz. Hello. I hope some people were able to join that can't normally make it because we just did it at this random time. But we'll get the next one scheduled and we'll keep plowing through these. So
This is awesome.
All right. Thanks a bunch, everyone. Good evening. And I will play the happy music that says thanks for watching.